Hello everybody. So on the bench today we've got a couple of solar panel charge controllers. My friend got these on Saturday. I don't think he paid anything for them, so they both were a bit suspect. And the small one, well, they're both made by Morningstar for a start. I think I've heard of Morningstar before. So the small one, I can't get it to work. I've basically given up on it now. I did find 3 diodes that were open circuit and soldered some diodes across the dead ones, and still does nothing at all, and it's not easy to work on. As is typical of everything, it's got some sort of hideous chip in it which controls everything. It's also the bottom part of the board is potted in down here, and it's got conformal coating on it, and basically I haven't got a clue what's wrong with it, so I give up on that one. But here we have another one. That's a big brute, this is. What's the ratings on it? The ratings are solar current 45 amp, low current 45 amp. So that's quite nice, isn't it? But if we look on the side of it, it says for display use only, non-working sample, manufacturer defect. Okay, so in theory it probably doesn't work. And initially when I plugged it in and I used my power supply at about 18 volts to simulate a solar panel, and for charging a 12 volt battery, and I used this rotten old battery here, which used to be, you can't read it now, but you just about can read it. It's a 12 volt 7 amp hour battery. Well, it was once. When I checked it on my electronic load, I think it gives about 2.5 amp hours now, but it is quite old, but it's still fairly useful if you want a portable source of 12 volts to test something. Anyway, that's beside the point. When I take the top off this, because you've got the connections by going in there, and these two are common, earth, and battery goes on that one, panel goes on that one, positives. And initially when I was testing it, it was charging, it appeared, the battery, but it took the battery up to about 16 volts and it was going higher and higher and higher. So I thought initially it was faulty, but what I did then was I did a search on this model number TS45, and I downloaded the manual for it, and of course you've got to set all those little switches for the correct configuration. That's probably a good enough word, and I believe it must have been set to 24 volts because I've now got it correctly set, and there's all sorts of strange things in it which I didn't quite understand, but I left those in what I thought was a reasonable switch position. And you can set the maximum battery voltage you want, so I set it to 14.6, and it's quite incredibly impressive really. You can do all sorts of different voltages and whatever, but obviously it's got another microprocessor in it, I imagine, it controls all that. So it's quite a sophisticated unit. So now we're going to connect it up, because I'm pretty sure it's working fine there on the 12 volt battery. Okay, so All I'm doing at the moment is just monitoring the battery voltage. Look, the Tesla is clipped onto the battery, and now I'm going to connect the negative of the battery to the charge controller and the positive to the battery connection when it will stay on. Okay, so now we've got a red light, which probably means the battery's low, 12.57. That's good. So power supply I've set to 18.5 volts, not important, just as long as it's fairly high. Current limiting 4 amp. So let's connect up the power supply when I can find the wires, because it's always difficult on this bench to find anything. There's negative on there. Those two are connected together anyway. Solar goes onto there, and turn on the power supply. And we look at the meter, it shows me the current it's drawing. That's a bit weird, isn't it? It's sent the voltage up on the power supply. They're bizarre. Not worry too much about that, but I think we can see now that we've gone past yellow from red and we're flashing green, and it's not going to take much to charge this battery because it's fairly crap battery. I'm already up to 14.2 volts, and I'm just going to leave it for a bit to see where it levels off, the voltage it levels off at. Okay, while we're waiting for it to charge, I thought it'd be interesting to see what it looks like on the scope, which is connected across the battery. This is what we get. You get a fairly nasty pulsy thing. I'm getting 125 millivolts of ripple on the battery caused by that controller. Whether that's important or not, I don't know. And frequency of the waveform, according to this, is 300 Hertz. That's what it says anyway. Interesting. And the duty cycle of that pulsy thing is at the moment around 7 or 8%. And I guess as the battery gets closer to be fully charged, it's on 14.4 at the moment, that pulse width will narrow. That's the way I think it should work anyway. So let's leave it alone and come back to it when it gets near the end of its charge. Okay, so here we are about an hour or so later. I think we've reached the end of its charge now. It's very close to 14.6 volts. And look at the power supply. It's only drawing less than 100 milliamps most of the time. And a quick look at the scope. That spiky thing is diminished in size down to 38 millivolts. Still a bit of squiggliness in the middle there. All sorts of strange things going on. And I don't know if that would affect some equipment. That turn that off. All those pulses. If you had sensitive amplifiers or something, they might pick that up. I don't know. But that's about it really. This one seems to be working fine. It's still blinking green, but maybe hasn't quite got to its full charge. It's near enough. And it's okay. It's the shame about this other one. It doesn't work, but never mind. That's the way it goes. So thank you for watching, and if you want to support me, I've never said this before, but there is a Patreon link and you can give me some money, please, because I don't make any money out of YouTube. I'm not important enough to earn money from YouTube. Anyway, thanks for watching. Bye for now.